I make learning a privilege, not a chore, and unconventional methods common. I'm a teacher. I make more.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at 100th anniversary of the Great Kern County Fair, and we're here
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. We've got our phone tutors here to help you with your math this afternoon. Give us a call here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free. It's 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And you can look for us on social media. We're on Facebook and Instagram, Twitter, and YouTube.
All right, well, you know what? Speaking of out of town,
Yes.
students that call in from San Luis Obispo County, when we do your math problem on air, you will be eligible. You're automatically going to win Doc Bernstein's Ice Cream Lab ice cream. So all you have to do is call in and go, hey, I've got this math problem I need to work on. We'll help you out with it. And because you used the service and got a little bit of help, we'll give you a little bit of ice cream.
Great deal.
So I bet you Mary Lou will be getting some ice cream out of the Kern County Fair. So we'll check in with those guys in a little bit. We have a special guest in studio, but before we do all of that, let's first take a look at today's Math in the News. All right, so one of the things that we do in class is in the GATE program, we do a lot of art and artists, study about them and the different styles of art and things like that. One of the things the students do is they're drawing people,
Right.
bodies, heads, and things like that
Faces.
also. So I found an article that was talking about ideal lengths and the ideal eyelash length. I didn't even know there was such a thing until I saw the article, but it fascinated me. It's supposed to be 1/3 the width of the eye. Okay, because sometimes you see people with eyelashes and they're more than 1/3 the width of the eye. They're probably the width of the eye.
The width of the eye, right.
And then some people have very, very, very short eyelashes.
Yes.
You know, it's like, do you have eyelashes? Yeah. But I guess there's an ideal length. So using that length, I was looking, all right, the ideal sizes for kids when they're using a scale to draw a full-size person. So the head should be 1/8 of the total size of the body that you're drawing.
Okay.
So if you are drawing somebody that is 6 feet, they're going to be 10 inches. How big should the head be? So if the whole thing is going to be 10 inches to represent a 6-foot person,
Right.
how big should the head be? Because some kids could draw a really large head on that person, and it wouldn't be proportionally correct. Some draw really small.
Yes.
But here's how you can figure it out. So you would take 1/8 of the 10 inches, which is 1/8 times 10, and then you come out to 1.25 inches.
So the body, the picture would be 10 inches for the entire body, and the head would be 1.25 inches.
Correct. And that's exactly how you kind of go about using that. But I figured that was pretty cool. Eyelash length, and we'll put that into some art.
And I know that the golden ratio figures into the proportions of the parts of the body also.
Right.
Yes.
Yeah, there's a lot of things that we could do with that. But we will be going out to the Kern County Fair in a little while. But first we have Serena with us. And how are you today?
Good.
Why don't you introduce, well, we already know you're Serena, but let everybody know where you go to school and what grade you're in.
I go to Stockdale Elementary and I'm in 5th grade.
How's 5th grade going?
Good.
It's all right? No problems?
No.
All right. What is the most difficult thing then about 5th grade?
All of the extra things that we do, like chorus and instruments.
So you're involved in a lot of things now.
Yes.
So is time management kind of something you're working on this year?
Yes.
Now, I understand because when I said, did you bring any math homework with you today? What did you say?
No, we don't have math homework.
Ah, there we go. That struck me as odd. We don't have math homework in 5th grade, okay? Now, it could be because you're doing a lot of work just in class and they want to see only what you're doing in class. But since you don't have any math homework, we're going to make you do other kids' math homework today.
Okay.
Okay, does that sound fine?
Yes.
All right, so that's what we're going to do. 636-4357, we do have phone tutors available, but I believe we're going to go out to the Kern County Fair and check in with Mary Lou.
We are live back here at the Great Kern County Fair, and I am with Michelle, who is with us from Science for Kern. How you doing today?
I'm great.
And we are here at the Chevron Pavilion, right?
Yes, we are.
And can you tell us a little bit what you do with Science for Kern?
Well, Science for Kern is a lending library. We have 8 different STEM units available for teachers to check out. We focus on 4th and 5th grade all over Kern County. Magnets, so I have the Magnets unit out here today. Magnets is just one of the 8 units that we have available. Teachers can go to my website, scienceforkern.org, and reserve one of the 8 units. And then I deliver the unit. I come with the unit. I do a demo lesson, get the teachers started on teaching the lesson, and they can keep it for 15 school days. And then I come back after the 15 days and pick it up, and then they can check out another unit.
Now, you say 8 different, so they're different all what?
Yes.
Can you give us an example of what one might be?
I have magnets, there's electricity, I have scientific method, I have matter and erosion, and the list goes on and on.
Okay, well, we have some examples. We have Buena and Antonia back over here, and they're doing some experiments. Can you tell us what they're working with?
Sure. So, this is, as I mentioned, this is our magnets unit, and one of the lessons has to do with polarity, positive and negative. So girls, I want you to take this, and I want you to try to float the magnets so none of them are touching. And take all 4 off. There you go, take the magnets apart. And then try to, they can't even touch the base. See if you can stack them on there without touching. This activity is called floating magnets. Let it go. Up, pull it up, modify in some way. So you can get it, there you go. Now put another one on and make it fuller. Excellent, I think you get the hang of it. And this is an example of an activity that teachers can use to teach positive and negative charges on a magnet. Attract and repel is taught through this lesson. Excellent, way to go.
Girls, it's even for teaching integers because the kids have to understand that when you have a positive and negative, that, well, it's not going to come together. This is excellent.
Right, exactly. Now over here, we have a plate of just regular office paper clips. Take this magnet, and I want you to pick up one paper clip and one with your hand, and let's stick it on there. And then hold it up. See how many more you can fish for out of the plate. That's great. Okay, let's try that again. One on there, and then see how many you can pull up one at a time, making a chain of paper clips. There you go. Oh, almost.
There you go.
Yeah, way to go. All right. So take them off. Now, does it matter where on the magnet you try to form your chain? For the tray, try the other side. Will it work the same? Excellent. Now let's try the electromagnet. Pick pick up the red horseshoe and hold it over the steel shapes. What happens?
It doesn't stick together.
Nothing, right? Absolutely nothing happens. Now, do you think that you could take the horseshoe magnet, the two alligator clamps, and our power source and hook them all up and have that power? Pick up some steel shapes. No? It's crazy little, those are tough.
There you go.
Got it? There you go. Hold it over the tray. Can you get them all? So what do you think must be happening in order for all of those to stick together? Because you'll notice they're not all touching the metal part. And how about here? What do you notice about what you've formed there? Why does it pick up steel shapes now and it didn't do it before? Right, so we call this electricity, and electricity flows in a circular pattern. Right now, pick any of the 4 clamps and let them go. Pull a clamp off and see what happens.
There you go. Pull one off. Just pull that off real quick. Just take it off.
There you go.
There you go. And it releases. All right. This is great examples of what you have. Now you are sponsored through
Chevron. Chevron is our sponsor.
Great. Well, thank you so much.
Thank you. Thanks for coming out.
Mike, back to you in the studio.
See all that science going on out there, as well as a little bit of math. And nice to see Michelle from Science for Kern, new to that position, and get her working.
Good.
That's exactly what we need to do. We have phone tutors available until 5:30. 636-4357 is that phone number. Toll free, the number's on the screen periodically throughout the program. Right now, we'll go to our first phone call. KAITLYN, how are you today? Hello, KAITLYN.
Hello.
And you're a 6th grade student at Reagan, correct?
Yep.
All right, as soon as you're ready, we're going to have you let us know what your problem is, and we have 2 tutors for you to work with today. As soon as you're ready, KAITLYN, let's hear it.
All right. The problem I am working on is -4, open parentheses, a plus 3, close parentheses.
I'm sorry, a plus 3?
Yeah, the letter A.
The letter A plus 3, is that what I heard?
How does that look, KAITLYN?
Yeah.
And then
-8.
minus 8?
Yeah,
I think
-8.
I think A, the letter A is an apple, or 8, the number?
A.
A is an apple.
The letter A.
All right, so the directions you have for this problem are what? Simplify? Is that what it asks you to do?
Yes, simplify.
All right, so do you know the 2 steps that we have to do to simplify this?
Yeah. Multiply the parentheses.
Okay, so let's get rid of the parentheses. So Serena, do you know what we're going to do? Do you know the distributive property by any chance?
Yes.
Yes.
So we're going to multiply that -4 times both of those. So have you worked with variables, Serena?
No.
So we're going to multiply -4 times a, which very nicely is just -4a, okay?
Yeah.
But then we're going to multiply -4 times 3. What's -4 times 3?
-12.
So we'll go ahead and write down the -12.
Negative
And then write the -8.
minus.
All right.
Okay, so your first step is, KAITLYN, is to remove the parentheses, right?
Right.
But we're not done yet, are we? What else do we have to do?
We have to bring the A down.
Okay, so we have the -4a and the -12 and the -8, right?
Yes.
And now what do we have to do?
We have to combine a like term.
So you notice, Serena, that one of the terms has an a, but these 2 are just numbers, aren't they?
Yes.
So go ahead and add those together. What's a -12 minus 8? Do you know what that is?
We haven't worked with negatives yet. We haven't
Well,
worked
what's
with
12 plus 8?
12 plus 8 would be 12.
Wait, what?
So, KAITLYN, what's 12 plus 8?
It's 20.
12 plus 8? You can't add that, can you?
Yeah, well, we have the -4a, right? But we have a
Oh,
negative
yeah.
12 and a negative 8, or a minus 12, minus 8. And these are just numbers, so what's 12 plus 8?
Negative 5A?
Well, except they're both negative, aren't they? So we're going to add them together.
12 plus 8 is...
If you add them together, what do you get 12 plus 8?
20.
20, so put down a 20. And since they're both negative, it's going to be a minus 20, isn't it? So put a
Negative 20?
So it looks like, to combine terms, we only have two like terms, the two numbers, right? And the minus 4a stays the same. So it looks like, KAITLYN, our answer is going to
Right.
be negative 4a minus 20. And since these are unlike terms, we can't combine those, can we? Some people try to add these together and get like a negative 24a, and that we can't do that because there's no a on that term. So there's our answer, okay? Thanks for the call.
All right, nicely done right there, KAITLYN, because you did get in with that problem right there. We're going to send you to the Kern County Fair. So congratulations on that. Do remember we have phone tutors available until 5:30 at 636-4357. Toll free, that number is 1-866-636-6284. Don't forget, you can also email any of your problems because we have email available, and that email address is dothemath@kern.org. Sometimes students email that in, and because they don't have time to watch the program, specifically between 4 and 5 o'clock live. So you can send that in previously,
Right.
or maybe tonight so we can get to it tomorrow. But it's always good to email it so that we can look at it on Tuesday or Wednesday.
Otherwise, you got to wait a whole week.
Right.
And yeah.
That's no fun to wait for your problem to be done that whole time. All right, we're going to go back. Another student from Reagan. Dixie, how are you today?
I'm good.
And are you working on the same type of a problem, doing expressions?
What?
Are you simplifying expressions or something else?
I'm simplifying.
Excellent. Back to the work.
Okay, let's try another one.
As soon as you're ready, Dixie, let's hear it.
3 in parentheses 2k plus 4 plus out of parentheses is plus 6. In parentheses is minus 5k. Out of parentheses is negative 1, and then in parentheses is negative 8.
Okay, so let me make sure I got all of what you just said. You said 3 and then inside parentheses 2k plus 4,
Yes?
and then plus 6 parentheses negative 5k, right?
Yes.
Nothing else is in there but the negative 5k?
Negative 5k is the only thing.
And then minus 1 times parentheses negative 8, right?
Yes.
Okay. So we know that in simplifying expressions, we got to get rid of those parentheses, right?
Yes.
And we have to combine terms. So let's get rid of all of those parentheses. So here's the distributive property again, right? So what do we get? What's 3 times 2k?
6k.
Well, we know 3 times 2 is 6. Go ahead and write down the 6k. And then we're going to do 3 times 4, right?
Yes, that's 12.
So plus 12. Now you notice we use the distributive property because we had 2 terms inside with the parenthesis, with the plus sign, but here we only have 1 term. So to get rid of these parentheses, all we have to do is 1 multiplication. So we're going to take 6 times negative 5k, right? Well, what is that? So what's 6 times 5?
30.
30s, so that's going to be a 30. And we have the k still, so put the k. And is it positive or negative?
Negative.
So because 6 times negative 5 is negative 30, we're going to subtract that 30k. Some people will write it as plus a negative 30, but we're just going to go minus 30k, right? Is that what you guys do?
Yes.
Dixie? Okay. And finally, what's negative 1 times negative 8?
Positive 8.
Yeah, negative times negative. This is what you'll get next year, Serena, is positive. That's just going to be 8, and it's going to be a plus. All right, so very nicely, in one step, we got rid of all of the parentheses, didn't we? But we're not done because we have to combine like terms. So what are the like terms?
6k and 30k.
So I'll underline those the same way, right? A 6k and a minus 30k. So what is 6 minus 30? So now we have to decide, what do you do when you have 1 positive and 1 negative? Remember the rule?
Minus the
You subtract, you minus, right? So what's 30 minus 6?
30 minus 6 is 24.
So right, let's go ahead, right? 24.
Right here.
Yeah, right there, it's fine. And those terms had a K, so put a K there. And now let's see. You said 30 minus 6 is 24, but we have 6 minus 30, don't we?
Yes.
So what's 6 minus 30?
Negative 24?
Negative 24. The bigger number is negative, so go ahead and put a negative sign in front of that 24. Okay?
Okay.
And then the other two like terms are just the numbers, aren't they? The 12 and the 8. And we just did a problem like this. What's 12 plus 8?
20.
12
20.
plus 8 is 20.
So we'll put plus 20 because they're both positive. So it's real nice to do everything and keep everything in order and do it right below so we can keep track of everything, make sure we get rid of all the parentheses. And then some people like to underline the like terms so that they don't miss any of them and they don't do anything extra. And have we gotten everything we needed to?
Yep.
We have 2 unlike terms and looks like we're done. Thanks for the call.
Nicely done, Dixie. Hey, if you're still on the line, guess what? We're going to be sending you as well to the Kern County Fair, so congratulations on that. You know, I like just handing out tickets. All the kids
Yeah,
let them go to the
that's
fair
nice.
for free like that. Serena, are you kind of getting the hang of this a little bit? I know you're brand new to simplifying expressions probably, right?
Yeah.
But after a few more, I'm sure you'll start getting the hang of it a little bit more. All right, we're going to go back to the phones. A lot of
Oh,
kids
one
calling
more,
in
all
today
right.
from Buena Vista.
Keep
Evan,
going.
how are you this afternoon?
I'm good.
And you are a 6th grade student, correct?
Yes.
And I know that you have called here before, and you are the same Evan that we were able to send out to CSUB last week with the Fab Lab, correct?
Yes, I am.
How was that experience? Can you tell us just a little bit about it briefly?
Yes. It was an amazing experience where we got to use laser printers, 3D printers to make a keychain. It was an awesome experience.
Good. Well, you know what? I'm glad that you had a fun time out there. And if you want to find out more at home about the Fab Lab out at CSUB, just go on CSUB's website, type in Fab Lab. You'll be able to find all that information. And as they were saying last week, anybody can sign up to go out there, make whatever you think of.
Yeah, the equipment they had out there that people could use and the materials, that really was amazing.
All right. Evan, as soon as you're ready, let's hear the math problem that you're working on.
Okay. The math problem is 4 start parentheses, d plus 3 end parentheses, minus start parentheses, d minus 1 end parentheses, equals 64.
Oh, good. We've
Ah,
moved on
now
from
we have an
expressions.
equation. So let me ask you, make sure, can you see the equation? I want to make sure we have it right? 4 times parentheses c plus 3 minus parentheses c minus 1 equals 64. Got that right?
Yes, that's correct.
Okay, so now let's go ahead and do what we've done, right? So let's use the distribute property. What do we get? 4 times c,
Would be
4 times c is 4c.
4c, so put that up. And 4 times 3,
Plus 12.
plus 12. Now, we don't have anything to multiply by here, do we? We have the parentheses, but there's no number in front, so it's just minus that. So do they have you put a number there?
Yes, we put
What?
the number 1.
So if you think of that negative, how many of these do we have? You have one of those sets of parentheses, don't you? So let's multiply by negative 1. Well, multiplying by 1 is easy, isn't it?
yeah.
1 times c is just c, but we have to take that negative with us. So what are we going to have?
Negative c.
Minus c. And negative 1 times negative 1. What's negative times negative?
Positive.
Positive. So that's going to be a plus 1. So the effect was, by multiplying by a negative 1, you just change the signs of both of those terms, the letter and the number inside the parentheses. Now we still have that equals 64, but we're not going to do anything with that. That's on the other side of the equation, right? We're going to work on one side at a time.
Yes.
Because what are we going to do with the left side of that equation before we try to solve it?
We're
What else?
going to combine like terms.
Now, we're still combining like terms. So we're doing exactly what we did on the other problems that we had before we solved the equation. So let's see, what are our like terms? 4c minus c. How many c's is that?
2.
That is
You have
plus
4,
3c.
and you take away 1, you have 3C. So write down 3C. And very easily, 12 plus 1 is
13.
13. So plus 13.
Yep.
And that all equals, that 64 is still over there, right?
Yes.
All right, so what we've done is just simplify that expression. This is what you've been doing before, isn't it?
Yes.
So now we're going to solve that equation. In other words, solve the equation means find the value of C, right? What number do I have to put in here for C so that this equation, this sentence is true? So what do you have to do to solve an equation, Evan?
We need to get rid of the plus 13.
Yeah, we need to get rid of the plus 13 and we need to get rid of the 3, right? So the C. So how do you get rid of that plus 13? How do you get rid of addition?
By subtracting.
So we're going to subtract. So right underneath that. Now, do you do it on the same line or do you do it below?
Below.
Below, okay. So right here under that 13, let's subtract 13. We've got this balance scale. Evan, did you guys talk about a balance scale with equations?
I don't think so.
No, now we're going to do, leave that here. So on one side, we did a minus 13, but whatever we do to one side, we have to do to the other, don't we? To keep this equation balanced. So on the other side of the equation, that's why we have this line. Over here, we're going to do a minus 13 also.
Yes.
And let's just do that subtraction. I'll do the easy part. 13 minus 13 is 0, isn't it?
Yes.
What's 64 minus 13?
That would be
51.
So go ahead and put that down. So on one side of the equation, you've got 51. On the other side of the equation we have 3C, right?
Yes.
We haven't solved for C yet, though, have we?
No.
We want to know,
No.
what does C equal? So how do we get rid of that 3?
By dividing by.
Now, why dividing? Why are you dividing?
Because since there's a 3 next to a variable, it always means multiplication, and we need to do the opposite of the function.
So we know that 3C means 3 times C, don't we?
Yes.
Even though there wasn't a multiplication sign there, we know it means multiplication. So that means to undo that multiplication, you said divide. So let's go ahead and divide. So go ahead and put a 3 underneath both of those. We're going to divide by setting up a fraction. 3 divided by 3 and 51. Again, whatever you do to one side, you have to do to the other side, don't you? Again, I'm going to do the easy part. 3 divided by 3, 1, right? So here was 0 because we were subtracting and they canceled out. Here when I divide, 3 divided by 3 is 1. And 1C is just C, isn't it? I don't need the 1 in front, do I? And what's, let me put an equal sign there, what's 51 divided by 3?
51 divided by 3 is 17.
17. So 51 divided, so our answer right here is 17. So it looks like the answer to your equation is 17. Is it?
Yes.
How do you know? Well, we didn't make any mistakes, did we?
No.
But what are you supposed to do with your answer to check your answer to an equation?
Put the number that we got next to the variable to check our work.
Yeah, so I'm going to take that 17 that I had here, and I'm going to go all the way back to the original equation and check our answer. Let's check it. What's 17 plus 3?
17 plus 3 is 20.
20, and I'm going to multiply that by 4. And what's 17 minus 1?
17 minus 1 is 16.
16, and I'm going to subtract that. We said negative 1 times 16. So what's 4 times 20?
80.
80 minus 16?
74.
I got to borrow.
64.
It's 64, and so our answer checks, doesn't it? Right? So once you get your answer down at the bottom, we go back to the first equation, check to see if it works. Okay? Thanks a lot for the call, Evan.
Nicely done right there, Evan. Do remember we have phone tutors available until 5:30. I think we were on a little run of expressions, and we may start seeing some equations coming through now. Hey, you know what? We'll be back out at the Kern County Fair right after this. Today we're at scenic Fraser Park, home of El Cajon School, and today we're here to... Well, this afternoon we're at El Cajon School, and with me right now I've got KAITLYN, a 7th grade student. And how long have you been at this school?
3 years.
3 years? This is your 5th year? Everything going well?
Yeah.
One more year?
Yeah.
All right, well, let's go ahead and work on a math problem right now. All right, so I'm going to read some information, and then you can mark however you need to. Okay? So, there was a student that rounded 10.68494 to the nearest hundredth. So why don't we go ahead, and how would you round this to the nearest hundredth?
You look at this number, and if it's 5 or over, you round this one up.
Okay, so you're looking at the 4 first, right?
Yeah.
And why do you look at the 4?
Because it's the next number after the hundred.
Right, because this is tenths, hundredths. So you're correct in looking at the hundredths and the number after it. And as you said, what is key with this? What do you do with that number?
You round it down because it's under 5.
Right. So what would this number round off to be? So go ahead and write the new number over there. Well, you said this number is going to...
Yeah, this one's smaller, so it makes...
So that's going to stay. There you go.
I'm just kidding.
Well, that's all right. The kid, I'm an old man. You can do that a little bit, all right? But so the 4 is going to keep this the same.
Yeah.
If it was a 6...
It would make this become 9.
Right, okay. So then you take the same number and round it to the nearest whole number. So what would that turn into? So you want a whole number now. And what were you looking at? How do you know this is 11?
That number, and it's over 5, so it makes this number change to the next one up.
Okay. And since we have 2 numbers after the decimal here, well, why don't you go ahead and put a decimal and put 2 numbers after that, which would going to be what?
Zeros.
Zeros, because that doesn't change the value. It's still 11.
Yeah.
We would like to know the positive difference between these 2 numbers. And all that means is what is the difference between the 2 numbers? All right, and what is the difference between those 2 numbers? How would you do that?
You would subtract 10.68 minus 11.
Well, you're going to go 10.6.
11 minus 10.68.
There you go. So go ahead and do that for us. So what is the difference between the 2 numbers?
0.32.
0.32. And how would you read that instead of saying 0.32? How else could you say that?
32 hundredths.
Perfect, 32 hundredths. But what I'd like you to do now is another step. Are you ready?
Mm-hmm.
I would like you to represent that as a fraction in simplest form. So explain what you did. So you took 0.32, 32 hundredths, you turned it into a fraction, which is correct, 32 hundredths. And then what did you do?
I divided that by a number that, the least number that can go into both of them, or the most number that can go into both of them, and then got 8.
And how do you know, like, is 825 the simplest form?
Yeah, because no number can go into both of them.
Right, so no number can go into 8 and 25, so you know you're in simplest form.
Yeah.
KAITLYN? Perfect.
Thank you.
Well, once again, we're at El Cajon, and right now I've got 8th grade student Emily. Are you well?
Yeah.
You feeling all right?
Uh-huh.
You're not nervous?
I am.
But everything's going to be fine. I promise.
Okay.
Now, you were saying that you have no idea what the problem is. Because all the other kids, they were like, oh, I kind of get an idea what's going to happen.
Yeah.
And we'll see, you're in 8th grade, so I'm not going to give you any clue.
Okay.
All right? So here we go. I'll read the problem to you. You write down anything that you feel is going to be important. What is the positive difference between 2 to the 5th and 5 squared? So, once again. So, the first number I gave you was 2 to the 5th. So, how would you write that? 2 to the 5th power. Good. And the other number was 5 squared, 5 to the 2nd power. And we want to know what is the difference between those two numbers. So first of all, there are some students that are going to be wondering how you're writing numbers like this and what those mean. So is there anything you can explain about the 2 and the 5?
Yeah, so it means that you do 2 5 times.
Okay, so this would be the base number, the 2,
Yeah.
and then you have an exponent of 5, which means you're going to multiply 2 5 times. So go ahead and write that out so students can see what that actually looks like. Right. Because sometimes a student would look at this and go 2 to the 5th and say 10. Right? Do you see how they might do that? But it's not going to be 10. So go ahead and show what that would be.
So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32.
Okay. And then if you would be so kind as to write out 5 squared the same way.
5 times 5,
Okay.
which is 25.
And the question is, what is the positive difference between those two numbers? So what would you do now?
Subtract 2
And
numbers.
what would you get?
5 minus 2, 12. 7.
That's it, right?
Yeah.
Okay, now the reason I had you do this problem is because sometimes a lot of students will go, well, the 5 looks bigger, so it's going to be a bigger number, but it actually became smaller, right, because of the exponent. All right? So 2 to the 5th is actually larger than 5 squared, and the difference between them is 7. Easy enough problem, right? All right, Emily, nicely done. And once again, a big thanks to all of the students and the staff up at El Tejon Middle School. We had a great time up there, and the kids were all fabulous to work with, so we hope that you guys are all able to view your little bit right there, because we let the principal know when your part is coming on so that you can watch that. Do remember we have phone tutors available until 5:30 on Tuesdays and Wednesdays. If you'd like us to come to your school, all you have to do is give us a call. The phone numbers are on the screen. Just say, hey, we'd like you guys to come on out, and we'll get some information and see if we can make it work. Right now, we're going to head back out to the Kern County Fair with Mary Lou.
We are back live at the Chevron Pavilion at the Great Kern County Fair. I'm here with Danielle and Maria.
Hello.
And they are with the Mix It Up Kids Club.
We are.
Wow. Now, can you ladies tell us exactly what your position is and what the club does?
Well, we are both directors. We own this together. So we decided that we come from a little bit of a background of a little bit of everything. So we decided to collaborate, put it all together, and it became this. We are a hands-on enrichment center for kids 6 to 18 years old, and we do culinary, science, engineering, tech,
Crafts.
robotics, coding,
Arts and crafts and yoga.
Now, do kids come to you after school? Is it an after-school program?
It can be used as an after-school program to where kids that are in public school come to us later in the day. We also will be offering weekend classes and stuff, so they can come to us then, but we also cater to homeschool kids as well. So we can do morning classes for homeschool kids.
Now, you have a facility, obviously?
Yes, we have a 5,500 square foot facility, and each section is dedicated. We have their own classroom, so science has its own area along with yoga, tech, so they have dedicated classrooms.
Okay, well, what is your most popular?
I would say culinary would be our most popular. Kids love to cook, and it's a lot of fun. We do everything from macaroni and cheese to Rocky Road fudge, and it's just
You got me right.
it's good.
Another popular thing is robotics and coding, which is what we have here for a
Okay,
year.
and we have again Buena and Tonya, and they have some really cool things. Can you explain what they have and what they're doing?
They have in their hands iPads which are connected to our Winter Workshop robots. They do coding and they can code them to do anything. Right now they're doing simple maneuvers. They can code them to do anything from playing musical instruments to obstacle courses.
Antonia, can I see real quick what you're doing? Can you show me real quick on the pad what you're hitting?
then this makes you go and then you can make it make animal noises, and then it moves.
Oh, that is very cool. It was easy to figure out.
Yeah.
Yeah. All right, we'll get on over there. I think we got a little race going on. All right,
tell
let's
them.
see. All right, Deanna, you ready? Okay, on your marks. Get set, go. Let's see who gets it. Oh, good job. And besides these are really cool because that's the first thing when I got here I saw.
That you
My
saw?
eye came to these.
Definitely.
These are really cool.
They are very neat.
Now, what else do you have on the table there set out?
This is just a little fun free time stuff that we have, which would be our marble towers. They're fun for kids. You build them up in the engineering portion, and then you get to run marbles through them. They're pretty neat.
Now, again, where's your location?
Off of White Lane in Grissa.
5601 Aldring Court, Suite A1.
Great. Well, thank you so much,
Thank
ladies.
you so
Thank you.
much. Thank you.
All right, Mike, back to you in the studio.
All right, looks like they have a lot of great things going on at that Chevron Pavilion right at the main entrance of the Kern County Fair. So if you're heading over there tonight, if you go in the main entrance right off of P Street, you'll be able to see Mary Lou, the rest of the Do the Math gang out there, and all of the different activities that Chevron is sponsoring out there this evening. So we'd like to once again say thank you to Chevron, a major sponsor here of our Do the Math program for many, many years. 636-4357 is the phone number. Don't forget, you call from San Luis Obispo. Doc Bernstein's Ice Cream Lab. You'll be getting some whatever flavor you want, I guess. But not a bad deal. Free ice cream for doing a little bit of math. Right now, we'll go back to the phones. Abraham, how are you today? Are you there, Abraham?
Yes.
And you're a student at Reagan, correct?
Yes.
As soon as you're ready, let's hear that math problem.
Okay, so my math problem is negative 3n, open parentheses, 1 minus 2n, close parentheses, plus 2, open parentheses, n plus 4, close parentheses.
Okay, did I get it all? Negative 3 parentheses 1 minus 2n plus 2 parentheses n plus 4, right?
Yes.
Okay, so now, Serena, we're back to expressions. So no equation to solve. So Abraham, what's the first thing we do?
We do negative 3n times 1.
And then we do negative 3n times
2n.
negative 2,
Negative
right?
2n.
So let's go ahead and do
Yeah.
that multiplication. Now, this is easy because what's 1 times anything?
3.
Itself, like minus
Itself. So
3n.
let's write down minus 3n, right? Minus 3n.
Yes.
And don't forget the negative in front.
Yes.
Now, what's negative 3n times negative 2n?
Positive 6n squared.
Because negative 3 times negative 2, negative times negative is positive, right? And n times n, we just looked on the student from El Cajon, we know that an exponent, right? N times n is n raised to the second power. So let's write that down. Plus, and we have a 6, n, have you used exponents, Serena?
Yes.
So write down n, and then raise it to the second power. Okay? All right, so there's our first set of parentheses. How about the second set? Same distributive property, right?
Yes.
What do we get? 2 times n?
Yeah, 2 times n and 2 times 4.
So plus
Plus 2n.
2n. And the easiest part of the problem is 2 times 4.
Yeah.
So what is that? Plus 8. Okay. So now we've got 1, 2, 3, 4 terms, and we've got to combine like terms, right?
Yes.
So what like terms do we have in this expression?
Negative 3n and positive 2n.
Right. That 6n squared has the same letter. It has an n in it, but it's being raised to the second power. So it's different than these two terms. And the 8 doesn't have an n at all, so it's different. So the only combining of like terms is minus 3n plus 2n. What is that?
Yes. Minus 1n.
So we can write down minus n. We don't need the 1, right? So just minus n plus 6n squared
Yeah.
Plus 8.
Yeah.
Now, do you leave your answer like that?
Yeah.
You can, right? So that's sometimes an acceptable answer for the problem they gave. But very often when they give you a problem like this with variables in different powers, very often they'll ask you to put it in order from highest power to lowest power. So very often if you look this up, say in an answer book, they'll put that 6n squared first, then the minus n, because that's n to the first, and then a plus 8 because it doesn't have a variable at all. So very often you'll see it in this last form instead of this form, just because they put the n squared before the n, before the 8. All right, and there's your answer. Thanks for the call.
Thank you.
All right, nicely done right there. 636-4357 is the phone number. We do have phone tutors available until 5:30 on Tuesdays and Wednesdays. One thing I'd like to bring to your attention are the stickers that we hand out, and these go out throughout all of Kern County. They go to every single school in Kern County. If you have not yet received these stickers in your classroom, all you have to do is give us a call, say, hey, I'm a student at this school, we haven't received those yet. We can kind of figure out, are they still in your office? Does the teacher actually have them? Have you gotten them yet? And we can pass them out if indeed we do need to send more out there. But those stickers have all of the information that you would ever possibly need to do on there. Are you nervous at all doing these problems?
At first.
At first, right? Well, because it was brand new to you, right? And you had no idea what was going on. But are you kind of getting the idea of how these expressions work?
Yes.
All right, there you go. So it's a good thing you're in there this afternoon. Get you ready for 6th grade and the end of 5th grade, okay? All right. You know what? We're going to go to the phones one more time. All right. Aiden, how are you today?
Good.
And you're a 6th grade student at what school? Aiden, what school do you go to?
River.
All right. As soon as you're ready, let's hear the math problem that you're working on.
My math problem is 7n minus 17 equals 4n plus 1.
Okay, let me make sure I got that right. You said 7n minus 17 equals
yes.
4n plus 4? So I got that equation correct? Okay? So what we're going to do is we're going to solve this equation. And remember, solving an equation means find the value for n, right?
Yes.
Okay? Which means when we're all done down here, we want n equals something at the bottom. So we've got to get all of those n's together and then get n all by itself. So Aiden, what's the first thing you're going to do?
You're going to add 17 or divide it?
Okay, so the question is, do you want to work with the variable term first or the number? You can choose.
Number.
Okay, so you said that minus 17, right?
Yes.
So we got numbers on both sides of the equation, don't we?
Mm-hmm. Yes.
But we want them all on the same side, so we have to get rid of them on one side. You said get rid of the 17?
Yes.
And how did you do that?
Add 17.
Right, so because it's being subtracted, so right below that, so we're going to go ahead and write plus 17.
And then it cancels each other out.
And then on the other side, to keep this thing balanced, right?
Yes.
We have to add a 17 over there, and we're going to add it to the 4. We're not going to add it to the 4n, are we? No. We're going to add it to the number. So just like before, I'm going to do the easy part. And you said minus 17 plus 17, that's 0, isn't it?
Yes.
Okay? And what do we get on the other side?
You add 17 to the 1.
So over here we get 7n, and over here the 4n is all by itself. And what's 4 plus 17? I'm sorry, did you say 4n plus 4 on this side?
No, 4n plus 1.
Plus 1, I'm sorry. So this is a 1. All right, so what's 17 plus 1?
18.
All right, so plus 18. All right, so we got all the numbers on one side. Now we got to get the letters over here. How do we get rid of that 4n?
We subtract 4, or we divide 4 by negative 4.
Well, let's see. We know that this is a positive 4n, right? It's being added to that 18. So how do we get rid of it? What's the opposite of adding?
Subtracting?
So you were right. We're going to subtract, aren't we?
Yes.
So below that 4n, so you're going to go ahead and put a minus 4n.
So we're going to minus the 4n or just the 4?
No, the whole thing. We're going to take care of that entire term, okay? By subtracting that 4n here. But again, whatever we do to one side,
We do to the other.
got to do the other. So over here, let's see a minus 4n into there. All right, so now let's combine those terms. Again, I'll do the easy part. 4n minus 4n just cancels out at 0. What do we have over here? 7n minus 4n. How many n's do we have? If we have 7 of them, we take away 4, we have?
3.
3.
So 3n.
Okay.
Equals, what's on the other side?
18.
The only thing left is 18, isn't it?
Yes.
So there's a new equation. 3n equals 18. How do you solve for n?
Can you repeat that?
So we have 3n equals 18. We want to get n by itself, don't we?
Yes.
How do you get rid of that 3?
By minusing the negative n on it.
Well, let's see. We have a 3n, right? That means 3 times n, doesn't it?
Yes.
We know that 3n has a multiplication between it. What's the opposite of multiplication?
Division.
Division. So now we're going to divide. So I'll show division by a fraction bar, right? What do we have to divide by to get rid of that 3?
3.
3. So let's divide both sides by 3. And 3 on the other side. And again, I'll do the easy part. 3 divided by 3 is
0.
well, it goes away, but it's 1, isn't it? It's just 1 n.
Yeah.
Equals, and what's 18 divided by 3?
6.
And 6. So it looks like your answer is n equals 6. What do we do with that answer? Do you have to check your work?
Yes.
So we're going to take that answer, n equals 6, and go all the way back up to the beginning. Let me do this check quickly. 7 times 6, we know that's 42, right?
Yes.
Minus 17. And here we have 4 times 6, that's 24, plus 1. Well, that's easy. 24 plus 1 is 25. What's 42 minus 17? It better be
25.
It better be 25, and it is, isn't it? So our answer checks, and n equals 6 is our answer.
All right,
Thanks for the
nicely
call.
done right there. You know what? We've got a few more minutes. Let's head back out to the Kern County Fair with Mary Lou.
We are back live at the Chevron STEM Pavilion at the Kern County Fair, and I'm here with Michael Coleman, Superintendent of Fairfax. How are you doing today?
Hello, how are you doing?
Good. Can you tell us who you brought with you today?
Oh, I'm excited. I brought here our Virginia Avenue STEM class. It's been some time. Really appreciative of Chevron allowing such a good focus on science. Fairfax School District is a real proponent of science. We have STEM classes at each of our campuses. So we're just excited to bring our kids here and share some time with you here today.
All right, let's check out what you have. All right. Hey, how you guys doing? Good. Okay, can you tell us what you brought today? A what?
A DIY lava lamp.
And a lava lamp. And how did you do that?
First, we took water, and then we took vegetable oil, and then we added food coloring, and then we took the salt or Alka-Seltzer, and then we stuck it in, and then it goes up.
Can you turn it and show us how it works?
Sure. It's easier to break it into 4 pieces. And then you put on the top.
There you go.
And then you take the light and put it under it or through it. But it's kind of hard to see.
Wow. Oh, I see it. Very cool. Impressive. Thank you. All right, next. Ladies, what have we got here?
We're going to represent friction.
Friction. Okay, how?
Friction, first we have these plates, and you can try this, and
Okay.
You can try to
Let Vienna get in there.
To rotate this, and it will be a little bit hard at first, but when you put soft surface like these foam balls, they're like round and soft, and when you try to turn it, it's easier and it turns itself.
Very good. Thank you. Hi. How you guys doing? Good. Okay. What do you have here? Looks pretty impressive.
It's a battery made out of pennies, oil, cardboard, and vinegar.
Wow. And is that really salt? Or is that just
This is to clean the pennies.
Okay. And how does this work?
You put the negative and the positive on the battery, and it gives out volts.
Wow. Good job, gentlemen. Hey, how's it going? Now, what is all this?
That is magnetic slime. Within it is the magnet.
The magnet. And how does it work?
All the iron fillings gather together at the top with the magnet, and it brings the slime with it.
Wow. And did you guys make this?
Yes. We had already made it as soon as we got it.
Very cool. Gentlemen, what are you doing over here?
Right here we made a circuit to control this fan right here. It's a miniature fan, and when we click right here, it closes the circuit.
When we hold the button, it'll close the circuit
so they can't
make the fan like
it'll stop.
turn on.
And then when we let go, it starts powering itself.
Impressive. And lastly, look what we have. We have Casey the Bull. How you doing? Hey, hello. What are we doing here, guys?
So here we're gonna do the challenge. Her and Casey have made a boat, and they're gonna see which one can hold the most pennies.
All right, let's go.
The record is 188 pennies.
All right, you got about 30 seconds. Ready, set, go. Count 30 seconds for me.
You can do it. Start putting them in there.
Come on! Oh, he's Nice job! Nice job, you guys! Nice job. Well, you guys, this is amazing. Thank you. And we want to thank everybody who participated today at the Kern County Fair. And thank you for having us today. All right, back to you, Mike, in the studio.
All right, thanks a lot, Mary Lou, and everybody out there with the Kern County Fair. And we saw Casey the Bull out there partaking in a little science activity. Well, Serena, since you did such a wonderful job this afternoon, we're going to send you home with a brand new uniform. So we'll turn this way so everybody can see that. Now, I know that your mom will be very pleased to know that you're going to wear this every day for the rest of 5th grade. Maybe not every day. How about every Tuesday and every other Wednesday? How's that? We can work out some sort of deal like that? All right. So, did you have fun?
Yes.
All right, good. I'm glad you had fun. Did you learn a little something with the expressions and equations?
Yes.
Very good, because you'll be doing those quite soon in school. What we'd like you to do is reach in there, and all the students that phoned in today are eligible to go see the Condors, and let's find out who's going. Vienna at Reagan Elementary. So congratulations to Vienna. You've got yourself 4 Condor tickets. Congratulations, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at Berkshire Elementary School, and we are here to do
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Give us a call with your math questions. We're here until 5:30 in Bakersfield. You can call us at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net. And we're on social media. You can see us on Facebook and Instagram, Twitter, and on YouTube.
All right, lots of different things going on.
Yes.
And we were just talking about this momentarily, about baseball season is now at the good part for a lot of people that usually don't watch baseball because the playoffs are starting.
That's right.
And your team is in the playoffs.
Absolutely, Giants.
That's right. And I'm going against my New York team, the Mets, and I'm actually rooting for the Giants.
Got to go with Mad Bum
win that
for
one
the
game.
Giants tomorrow.
Did you know that today is Trucker Day?
I didn't. I thought it was Taco Day.
Well, it's Trucker Day because it's 10-4.
10-4, got it.
Yeah, I heard that
Good,
on
buddy.
the radio somewhere. I was like, all right, yeah, 10-4, all right, it's Trucker Day. Anyway, it is a big day. We do have phone tutors available until 5:30. A lot of screaming eagles out there at Berkshire Elementary.
Yes.
I believe they're the Eagles.
Eagles.
I don't know if they're
Okay.
screaming Eagles, but they were at that moment. We have a very special guest in studio and a lot to get to, but first, before we do all of that, let's first take a look at today's Math in the News. So there was an article about copyright pages and the numbers that are on them.
Okay.
Okay, so I pulled up a couple of pages from books with, it's just got a lot of numbers on there right now.
Right.
We can see that this book was published, copyrighted 1978, University of Chicago. And then there's the numbers down here. And a lot of people, well, what's up with those numbers? So we found another one. And we can see
lots of numbers.
The copyright is 1981, but these numbers are quite different from the last one.
Right.
Right. So these ones are going 15 all the way back to 2, but don't include the 1. And the other ones were pretty weird also. And then I found another example, and this just goes 10 back to 1. So there's a lot of different things going on here. And the article that I found talks about the numbers on these copyright pages.
Okay, good.
While different publishers use different conventions for these number lines, generally speaking, the smallest number in the line indicates a book's printing. So if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's a first printing.
Okay.
So they're including the number 1. If the number 1 has been removed, so it's 2, 3, 4, 5, 6, 7, 8, 9, 10, it's the second printing.
Okay.
So if the number 3 was removed, it would be the third printing. The reason they remove a number instead of just changing a number has to do with the way publishers have historically printed the books. In offset printing, you can relatively easily remove something from the printing plate, but adding a number would require a whole new plate.
So that's why they have the numbers from 1 to 10, so they don't have to add numbers. They just
right. So they can remove it every time instead of making a whole new plate just for that page.
When printing used to be mechanical and hard to do.
Then depending upon the publisher, the number line might also indicate the year. So it might say 2, 3, 4, 5, 6, 93, 92, 91, 90. reveals that the second printing was done in 1990, and then once again, you take a number off each of those so that you can see what edition it is and what year that printing happened. So I was like, all right, that's pretty cool. Those are sequences of numbers.
And interesting conventions that we still have, even though they really don't have that problem anymore.
Antiquated, but still useful in the way it's going. So
Tradition.
I figured, let's take a look at some number sequence. A sequence in mathematics can be a string of numbers that follow a pattern. The elements in a sequence are called terms. One of the simplest can be found in multiplication. So we have 3, 6, 9, 12, 15, etc. The pattern is to add 3 to the previous number to get to the next number. So I figured, all right, that's nice. Kids are looking at that going, all right, number sequences, I kind of get that, but I want to see some sequences. So here's some sequences. We have triangular numbers, square numbers, cube numbers, Fibonacci numbers. These are all sequences, and there are hundreds of other ones. And then it's simply try your own sequence. So in studio with us right now, we've got Justin. How are you today?
Good, sir.
Have you ever seen triangular numbers before?
Yes.
Where have you seen those? Or can you tell me what the pattern is here? What's going on?
When you put them in the rows of dots, they'll make a triangle.
Right, exactly. So if you just make the dots, like if you put 1, and then underneath you've got the 2, and then together there are 3. And the next row you would have 3 on there, so you would have a 1, a 2, and a 3 to make up the total of 6. So you can see that, and you can see here you're also adding 2, add 3, add 4, add 5, add 6, and we can do it like that to figure out the numbers without having to actually make all those dots, right?
Right.
Have you ever seen square numbers, or what's going on here?
Yes.
Okay, why don't you tell us a little bit about
The
that?
numbers multiplied by themselves.
Right. So 0 times 0, 0.
And geometrically, if those are triangles up on top, what can you do with square numbers? If you can make triangles out of those top numbers, what can you make with the square numbers?
Squares.
Squares.
There you go, all right? So 2 squared, 3 squared, 4 squared, and so on, right? What about cube numbers?
You can put them in cubes if you use them as dots.
And so we're going to go 1 to the 3rd power, 1 cubed, so it's 1 times 1 times 1, 2 cubed, 2 times 2 times 2, 3 cubed, etc., right?
Right.
Fibonacci numbers, have you seen these before?
Yes.
Explain a little bit about what you know about these numbers. What do you see in this sequence here?
The next number is the last number added by the number before it.
There you go. So 0 and 1, we add them together, we get 1. 1 and 1, we add them together, we get 2. 1 and 2, we add them together. See, we have that sequence right there. Now it says try your own sequence. What kind of a sequence do you think you would come up with?
Something like multiply by 3.
Multiply by 3?
Yeah.
Kind of like what we were doing at the beginning? Well, that's it. You know what? Anybody can make any type of sequence they want. And that is today's Math in the News. Number sequences and how we got to those from the copyright pages out of any book that you take a look at. 636-4357 is the phone number. We do have phone tutors available until 5:30, but in studio with us, I waved you up here to help me out with that. And Justin, why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary and I'm in 5th grade.
Everything going well in 5th grade?
Yes.
Nothing difficult yet?
No, not yet.
All right, well, I guess we're going to have to give you some difficult math problems today. How's that?
Sounds good.
All right, well, we'll see if you still say that after we give you the math problem. Anyway, we're going to go to the phones right now. And John, how are you today?
I am all right.
All right, what grade are you in?
I am in 6th grade.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. The answer I am working on is parentheses 12 plus 10 plus 8 plus 6 plus 4 plus 2 parentheses. Division sign.
Okay, so all of those are in parentheses, and then a division sign like the line and 2 dots?
Yes.
And you're gonna, because I'm gonna stop you for a moment, because if you keep writing this way, you're not going to have room. So instead of putting the division symbol like that, why don't you just draw a fraction line?
So is that okay?
Everything you've got?
I'll do division by putting everything you're going to give me next underneath it. How's that?
Okay.
Okay, that's the same as division. Okay. And what do we have on dividing by?
Parentheses 6 plus 5 plus 4 plus 3 plus 2 plus 1. Parentheses.
And then plus 1 and in parentheses?
Yeah.
Okay? That's the problem, and you just have to solve that or work it out?
Solve it.
Okay. So what have you been doing? Have you been working with, well, let's see, we just talked about sequences of numbers with parentheses. How about this series of numbers that we add together? Have you been working with these?
Yeah.
Do you have a trick for doing this, or do you just add these all up? What do you get?
So I got 42.
Pardon? You added the top together and you get 42?
42. Yes.
Okay. So did you just add them 12 plus 10 plus 8 plus 6 plus 4 plus 2?
Yes.
Is that what you did? Okay. And you got 42?
Yes.
Do you know there's another way of doing this?
Not that I heard of.
Well, if you add 12 and 2, what do you get?
14.
14. If you add 10 and 4, what do you get?
14.
14. And if you add 8 and 6, what do you get?
14.
And what's 14 plus 14 plus 14? Isn't that just 3 14s?
Yes.
And you know what that is? 42. So you could take 14 and multiply it by 3 because you had 1, 2, 3 14s. And you can get 42 that way also, couldn't you? All right, what'd you get on the bottom?
Okay, I added them all together.
And what'd you get?
I got 20, hold on, 21.
21. All right, so you added 6 plus 5 plus 4 plus 3 plus 2 plus 1, didn't you?
Yes.
There's a little, I don't want to say it's a trick, but it's a way you can do it and almost do it in your head. What's 6 plus 1?
7.
7. What's 5 plus 2?
7.
And 4 plus 3?
7.
How many 7s do you have?
3.
3. 3 times 7 is? 21. So that's a way of checking your work, right? Especially if you have a long list of numbers and you have big numbers, that might be a way of checking your answer. So top is 42. We've done it 2 ways, haven't we? The bottom is 21. We've done it 2 ways, haven't we? So what do you get for an answer?
2.
42 divided by 21? It's 2, isn't it?
Yes.
And something that you might notice in this problem that's interesting is, what's 12 divided by 6?
2.
And 10 divided by 5?
2.
And 8 divided by 4, and 6 divided by 3, and 4 divided by 2, and 2 divided by 1. Notice that all of those, even though they're separated by plus signs, they all give us a 2. But when you add them all up, you don't get 2 plus 2 plus 2 plus 2 plus 2 plus 2, do you? You get just 2 as your answer. Interesting, isn't it?
Yeah.
That's the answer. Thanks for the call.
There you go. Nicely done, John, for that great phone call right there. We're going to send you over for a free meal. Our friends at Johnny Rockets and Lydia will be glad to see you. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Don't forget, if you call from outlying areas of Kern County as well as San Luis Obispo, the phone number is toll free at 1-866-636-6284. When you call in from San Luis Obispo, we've had kids calling in from Boron and a lot of outer areas today so far. But if you're calling from San Luis Obispo today, you will be getting yourself some free Doc Bernstein's Ice Cream Lab ice cream. You like ice cream, Justin?
Yes.
What's your favorite flavor?
Chocolate.
Chocolate? You know what? I think when we went over to Doc Bernstein's, we had a base of chocolate and we did something else to it. And it's going to come out pretty soon. And if you ever go over to the Central Coast, you need to look up Doc Bernstein's Ice Cream Lab. Tell them you were on Do the Math and see if they have that ice cream flavor for you that the math ones. All right?
Okay.
So as soon as it comes out, we'll let you guys know about it, and then you can go over and check it out. Sound good?
Sound good.
All right. Right now, we're going to go check it out with Berkshire Elementary and Mary Lou.
Thanks, Mike. We're here at Berkshire Elementary School, the ACES After School Program, and I'm here with Fernando today.
Hi.
How you doing, Fernando?
I'm doing good.
And what grade are you in?
I'm in the 6th grade.
Ah, have you been here since kindergarten?
Yes, I have.
Have you just absolutely loved your campus here?
Yes, I have.
Gonna be sad when you leave?
Sort of, yeah.
Well, Mike was back in the studio talking ice cream. What's your favorite flavor?
I like plain vanilla.
Oh, just plain vanilla?
Yeah.
All right. Okay, now you said earlier that you have been on TV before.
Yes, I have.
And it was with the news. And you said something about pet adoption.
Yes.
Can you quickly kind of tell us what that was for?
The pet adoption?
Yes.
Yes. So they're having pet adoptions at a local adoption center. And what they did was they took a quick scan of all the dogs, and the little pound showed what they were doing. And they showed up a little quick scan of me and my sister checking out the dogs, filling out the papers, and stuff like that. And it was like really sad how we saw all the dogs just sitting there in the corner.
They wanted to be adopted.
Yeah, they
didn't
wanted
just
to be
makes,
adopted.
Makes you want to just take them all
Yeah.
home with you, huh? All right, well, let's look at this math problem that we have here. It's a word problem, obviously. So it says a school cafeteria has a restriction on the amount of sugary drinks available to students, which is a fact, I know that, at schools. Drinks may not have more than 25 grams of sugar based on this restriction. What is the largest size cola the cafeteria can offer to students? And we need to know in ounces. Now we have a chart started here. We have for 6 ounces of cola, the amount of sugars is 20 grams. The first thing we need to do is, can we simplify this? Because this is actually a fraction, isn't it?
Yeah.
Okay, can we simplify that fraction down?
To find the simplest fraction, you could divide the number either by itself or by a lower factor, I guess. Yeah, factor. And in this case, we could divide by 2, which would give us the fraction 3/10.
Okay, why don't you write 3/10 underneath it? Oh, here you go. I'll switch with you. Okay.
Thank you.
You're welcome. So that 3/10, does that represent if we have 3 ounces of cola, then we have 10 grams? Okay. What if we had 7 ounces?
7 ounces?
Yeah, let's put a 7 there. How can we determine how many grams? What are we going to multiply that by?
Multiply by...
We can multiply...
2.
What do you think? By 2?
I guess, yeah.
Okay, because we have 3 over 10, right? So we want this fraction to simplify to 3 over 10. Let's try another one. Let's try 8. Let's throw 8 in there.
All right.
Let's see. Can we throw an 8 in there? Okay, is there one that we can do like 8 where simplifies to 3/10? You think?
No.
No? Okay. Why don't we do this? Can we multiply both of these by 2 to make an equivalent fraction? Okay, we could do that too. So what is 6 times 2?
12.
Okay, so if we have 12 ounces of cola, we have how many?
40 sugar.
Okay.
40 sugar grams.
And let's go ahead and multiply this by, well, let's multiply this by 3. What's 6 times 3?
18.
Okay. Let's go ahead and multiply this by 3.
60.
Okay.
60 grams.
Now, what about 6 times 4?
24.
Okay. And 20 times 4?
We're going to get 80.
Okay.
80 grams.
And what about, we're at 6 times, let's see, 2, 3, 4, 5. 6 times 5.
We're going to have 30 ounces.
And 20 times 5?
We're going to get...
100?
Yeah, 100 grams.
There you go.
I got last there.
And last one is 6. 6 times 6 is?
6 times 6 is 36.
Okay.
36 ounces.
And 20 times 6?
We're going to get 126 grams.
120,
Oh,
right?
yeah, 126. No, 20, sorry.
There you go. And these are just fractions, right?
Yeah.
And if we actually simplified them all down, do you think we're going to get 3/10?
Yes.
Yeah, we are. Because they're all equivalent, aren't they? But again, now we need to look at the question again. It wants to know, we can't have any more than 25 grams. So what can the cafeteria sell to students?
They could sell at least 24 ounces of cola.
Okay, but let's see. But the sugars can't be any more than 25 grams. So if you said, what did you say, 24? But how many grams?
Ooh, we have 80.
That's 80 grams. Is that too much?
Yeah.
That's too much.
My eyes were sticking.
So what do you think? We need to go less than that.
Yeah.
Which one? We need something with 25 grams or less. Where do you think?
Maybe 6 ounces?
6 ounces, yeah, because if we go to the 12 ounces, is that too much? That's too much, isn't it? So looking at this, 6 ounces, so we know they can sell at least 6 ounces, don't we? Because there's only 20 grams. But with 12 ounces, that's 40, isn't it? So let's go ahead and circle that, okay? There we go. All right. Yes, I know that schools, cafeterias have to watch the amount of sugar on drinks, huh?
I'm nervous.
We don't want a really sugary drink. You did a great job.
Thank you.
All right, Mike, back to you at the studio.
All right, thanks for that, Mary Lou. And Justin was saying his favorite sugary drink is Pepsi. Pepsi, right? You can't say Coke if you say Pepsi, right? Those two are like big feuds right there. Anyway, we do have phone tutors available until 5:30. We've got a couple of other phone calls to get to, but first we're going to make Justin do a little bit of work. So head on over to the board. This is a problem that was emailed to us by a 4th grade student, and the problem was 43 times 6. And they said we have to use multiplication, but they want estimation. Now the thing is, I'm going to have Chuck work with Justin. When you just say we need to estimate it, there are a couple of different things we can do, so take it away, boys.
Right, so let's start over here. And so how can we estimate, instead of actually just multiplying 6 times 43, how do you estimate something like that?
You can do 40 times 6.
Yeah, so you can say 43 is pretty close to 40, so let's write that down here. Write down 40 times 6. And so we just rounded off that 40 to the nearest tens, right? Because it's a nice round number. And what do you get if you multiply 40 times 6? This is easy to do in your head.
240.
You can do that in your head, can't you?
Yes.
So estimating should be pretty easy once you round it off. Now, how else could you round this off? So we have 43 times 6. You rounded off to 43. What could we do with that 6? What's that close to?
5.
It's close to 5, because that's a nice number to multiply by. So you could go round that 43 off to 40 and do it times 5. That's another estimate. So it's pretty close to 200. Now you rounded down to 5. What if we did it by tens, like we did this by tens? What if we did that by tens? We could have a 40 on top, and what would we have on the bottom?
10.
10, because that's pretty close to, well, it's more than halfway to 10. So another estimate could be 40 times 10, which is, again, real easy to do in your head, isn't it? It's just 400. Let's see, is there any other we could round that off to? So let's see, we rounded off the 40 and left the 6 alone. What if we left the 43 alone and rounded off the 6? How about if we started with 43 on top and rounded that 6 up to 5? Yeah, what's that? That one's not so easy to do in your head, is it? What's that going to be?
$215.
So 215. And let's do the same thing. We rounded it down to 5. What if we rounded that 6 up to 10 and left that as a 43? $430. So what do you think? Which one do you think is probably the best estimate of this?
40 times 6.
Let's see. Let's go ahead and multiply that out. Go ahead and multiply 43 times 6, even though it didn't ask him to do it in this problem to estimate. Let's see which one of these. We've got, what, 5 different estimates here. Which one do you think is closest? So let's see, 240, 200, 400, 215, 430. So it looks like your first one was pretty close. We were only 18 off. This is way too big, right? 430. Right? So some good estimates, and again, depending on the problem, you'd get one of those answers.
All right, there you go. Nicely done, and thank you for that emailed question from that 4th grade student. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we'll go back to the phones, and in just a moment, we're going to get back to there. So what we're going to do is we're going to tie in some different shapes and the number of sides. So right now we're going to go back to Michael from Castle. How are you today?
I'm good.
And what grade are you in?
I'm in 6th.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. A pentagon is an 11-sided polygon.
So what was that, hen? Did you say hen?
Yes.
Hen decagon?
Yes.
Okay. Okay, that's 11 sides? All right. And what else do we have?
What is the product of the number of sides of a pentagon and a square?
And a square. So we want to multiply the two numbers that are the number of sides. So you've already given us the number of sides in a hendecagon. I'm glad I don't have to draw that. That's 11. And well, we just need to know how many sides in a square?
4.
4. So that's going to be 4 sides, isn't it? So you just have to multiply it. Now, did they tell you that a hendecagon was 11 sides, or did you have to know that?
It told me that it was 11 sides.
But it didn't tell you that a square had 4, right?
Yes.
So that you needed to know that. So what did we need?
We needed to find the product of a pentagon and a square.
Find the product. So the question now is, what operation is product?
Product is multiplication.
Right, product is multiplication. So you need to know, right, the difference between a product and a sum and a difference and a quotient, right? So this is the answer to a multiplication problem. So what two numbers are we going to multiply?
11 and 4.
So let's go ahead and do that. Let's go ahead and multiply 11 times 4. That's probably the easiest part of the problem, isn't it? 11 times 4. And what's your answer?
40.
Write it down.
44.
So I'm pretty sure that they knew that you could multiply 4 times 11. So the things that you really needed to know in this problem is how many sides in a square, right? And you needed to know what a product was. You didn't want to add those two numbers. You didn't want to subtract or divide them. You wanted to multiply. So that's really a good problem because as easy as the work was to get the answer, you still had to know those two things in order to do it. Right? Thanks for the call.
All right, nicely done on that, Michael. Do remember we have phone tutors available until 5:30. We'll be back with more right after this. Today we're at scenic Fraser Park, home of El Cajon School, and today we're here to... Once again, we're at El Cajon School, and right now we've got 8th grade student Sadie with us. How are you, Sadie?
Good, how are you?
I'm well myself. Go ahead and read that problem for us.
That is 3x plus 5 equals 18.
What do you think I would like you to do with that problem?
First, we would need to do order of operation, which you would minus the 5, which is opposite math.
Okay. But what do you think I'm eventually looking for?
To solve for x.
To solve for x?
Yes.
But I don't want you to do that. I want you to tell me what 6x will equal.
6x?
Yeah. So first of all, before you can tell me what 6x is equal to, what do you have to find out first? What x is equal to.
Yes.
So go ahead and go through this problem and solve for x first.
Okay. So first, we would do opposite math. And you'd cross that out. 13. I'm going to do it like this. 3 goes.
So for everybody watching right now, you went minus 5 because you said you were going to do the opposite, right? Yes. So the opposite inverse of addition is subtraction. So you're going to subtract 5 from both sides. because it's kind of like a balance, right? Whatever you do to one side, you have to do to the other side. So we went ahead and did that. So you divide, or you subtracted 18, took away 5, you got 13. So now you have 3x is equal to 13.
Yes.
Okay? And we want 6x. Okay? So what are we going to do here? Here, instead of doing what you did there, okay, because I saw what you were doing there, okay, and I said, yeah, let's figure out what x is, all right? So take a look at this. 3x is equal to 13, okay? So if I have 6x,
Equal to 13.
well, if 3 is 13, what is 6? What did we do here?
We multiplied
By what?
by 2.
So what do we do here?
Multiply by 2.
So, see, the question was, what does 6x equal to? Because what I let you do is go ahead and say, all right, we're going to solve for x first, and then go ahead and multiply by something else, but you don't even have to go through that whole process. See, because once we get to 3x is equal to 13, we want to know what 6x is.
Okay.
So, do
And
you
so
see how
you-
we just simply did that? So if I said this, I want to know what 9x is.
Then you would multiply 26 times 2.
Well, instead
Well,
of
no, you would just do,
because we went 3 times, if we just went from 3 to 9, what do we do?
then that was 3 times 3.
Right.
And so 9 times 3.
So now we're going to go 13 times 3 is going to give us.
Can I do it out? 39.
There you go. So you see how that pattern goes?
Yeah.
See, if 3 is 13, 6 is 26, 9 is 39, we don't have to do all of the other division. If I said 12x, now instead of multiplying, what else could we do? Because here I'm just increasing by what?
By 3. No.
By 13s, right?
Yeah.
Is
So
that the goal
then-
for you to go to class? I'm only kidding. So if we're just simply adding 13 every time, what do you think we're going to do?
Add 13 again.
Okay, so add 13 again, what do we get?
$52.
52. All right. So, because there are going to be problems where it says, I want to know the value of 6x. If you know 3x is 13, simply double this. You get to 26 and you get to the problem a lot easier. All right? Sadie, nicely done.
Thank you.
All right. And once again, a big thanks to all of our friends at El Cajon School up there. We do have phone tutors available to that came out really quick, didn't it?
What time is that?
Right over at 5:30, as always on Tuesdays and Wednesdays. But before we get back to the phone calls and making Justin do more work in studio, we're going to first of all go out to Berkshire with Mary Lou.
Thanks, Mike. We're back here again at Berkshire Elementary School, ACES After School Program, and I'm with Selena. Hello. How are you doing today?
I'm doing good.
And what grade are you in?
6th grade.
6th grade. What's your favorite thing about 6th grade?
My last year here at Berkshire.
Oh, that's really special, huh? Make sure you have a fun year, right? All right. Okay, so Mike has been talking all day about sequence. We have something that's a sequence, don't we? It's a ratio, but it's really kind of a sequence, isn't it? So it says Selena solves 3 math problems in 4 minutes, and we need to complete this table, right? So yeah, it is a sequence, isn't it? So we know that she solves 3 problems in 4 minutes, and that's what the information we need, right? So here we have number of questions, which are 3. Number of minutes, Selena, what are we going to put there?
4.
Okay, let's put a 4 there. Now here we have it started. If we have 6 questions, then how many minutes is it going to take us?
8.
8. How did you get 8?
Well, 4 times 2 equals 8.
Exactly. So we're just timesing by 2 here, aren't we? That's our pattern. Okay, let's put 8. So here we went 3, 6. What do you think we're going to put here?
9.
9. And 3 times what is 9?
3.
Okay, I'm going to let you put the 9 there. And what are you going to put in this box?
12.
Okay, because 4 times what?
4 times 3 is 12.
Exactly. And again, we could clearly see our pattern because here's times 2, here's times 3. This is going to be times
4.
Okay. Go ahead and fill in those boxes for us. And then, so if this is times 4, this is?
Times 5.
All right. So 3 times 5 is?
15.
And 4 times 5 is?
20.
There you go. So what's next?
Times 6.
I'll let you write that up there. Okay, so 3 times 6 is?
18.
And 6 times 4?
24.
Instead of keep saying times, which we know we're going to go times 7, and we know we're going to go times 8, times 9, and times 10, can you just quickly do this with a pattern of adding 3? Okay, let's go ahead and finish off our number of questions and tell us what you're putting in there.
Okay. 3 times 9 is 27, and 3 times 10 is 30.
Okay, now let's go ahead and finish off our number of minutes. And we have our 4 times 8, which is?
32. And 4 times 9 is?
Just add 4, yeah, add 4 to that.
36.
There you go.
And then 4 times 10 is 40.
And another great thing about this, okay, these are all ratios, aren't they?
Yes.
They're all fractions. And if we actually simplified every single one of these, Selena, guess what answer we would get if I simplified all of them? What did we start with? 3/4. So every single one of these are equivalent fractions. And that's what a ratio is. A ratio is equivalent fractions, right? Equal fractions. Well done, well done. All right, Mike, back to you in the studio.
All right, thanks for that, Mary Lou. All right, we have some other phone calls to get to, but first we're going to put Justin back to work. Over to the board, young man. This is a problem you will do in 6th grade and probably in 7th grade and 8th grade, but since you're in 5th grade, we're going to give you a head start on it. Because this is a problem that someone emailed us, so we need to go ahead and work on it today. 2k, open parentheses, 4 minus 3k, close parentheses, minus, open parentheses, and negative 3, close parentheses, plus 2k. And Justin, what you need to do is you need to simplify that expression.
There's a lot to do in this problem. We've been seeing some of these with simplifying expressions and then also some equations. But do you know what we're going to do to start this problem?
This part.
Yeah, so let's do this first part, and you can write it down here. We're going to do this set of parentheses, and that means we're going to use something called the distributive property, right?
Right.
So we're going to multiply 2k times 4. What's 2k times 4?
8k.
Yeah, you know that 2 times 4 is 8, so let's go ahead and write that down. That's 8. And the variable just stays with it. Okay, now we're going to multiply 2k times 3k, and we're going to subtract it, aren't we? Or some people will say 2k times negative 3k. But let's go ahead and go 2k times 3k, that's what?
6k.
6, so that's 6. 6K. And it's k times k.
K squared.
K squared. We talked about squared numbers. These are raised to the 2nd power. Yes. So let's go ahead and write that down. Minus. So we're going to go ahead and write down that minus because it's subtraction, and 6k squared. All right, so we've gotten rid of these parentheses and got 2 terms. Now we've got to get rid of these parentheses, but we're not going to use the distributive property because we don't have any operation here. We just want to take, have you worked with negative numbers?
No, not yet.
Well, so what we're going to do is we're going to work with a negative number. And I'm going to ask you a question. What's the opposite? What do you think is the opposite of negative 3?
Plus 3.
Plus 3 or positive 3. So let's write that down. Instead of minus a negative, we're going to write plus a positive 3. And then let's go ahead and write down that plus 2k. We're not going to do anything with that. We're just going to rewrite it. So the first step in doing these problems that we've been doing for the 6th graders that have been calling in is get rid of all of the parentheses. That's pretty easy, isn't it? Yes. Here's the second step. We're going to combine like terms. Now, what do you think like terms means?
Related terms. Related terms.
So related terms, right? They're going to look alike or they're going to be related. So you notice that some of these numbers have a number and a k. Some of them have a number and a k squared, and some of them have just a number. Which ones look like they're related or like terms?
8K.
8K and
2K.
2K. They have a number and just a k, not a k squared. So those are the two numbers we're going to combine. And you notice we're going to combine them. We're going to take an 8K and a plus 2K. What do you think that is?
10K.
10K. So write down 10K. There's only one 6K squared, so let's write down minus 6K squared, because there's no other like term there, is there? And then there's nothing, so I sometimes can do this, right? Underline that twice. And then the 3 is also all by itself. I'll underline that 3 times, and it's all by itself, plus 3. And so if you simplify this expression by removing parentheses and combining like terms, you'll get an answer of 10K minus 6K squared plus 3. Or sometimes they'll have you put it in order. We talked about K and K squared and K cubed with cube numbers.
Yes.
A lot of times the answer they'll put it in order, and they'll put the K squared term first, then the K term, and then the number. And you notice that the minus went along with the 6. That 10 is positive, isn't it? So we had to put a plus in front of it, and the 3 is positive. So you'll also see an answer something like this. And there is your 6th grade work for today. Right?
All right, well done right there. Hey, come on over, Justin, because you've done a 4th grade problem sent in by email, and now a 6th grade problem done by email. So we're going to go to the phones right now with Daniel from Stockdale. How are you today?
Good.
And you're a 6th grader?
Yes.
All right, because Justin said he might know you, so let's go ahead and hear what problem you're working on.
Okay. 2.3n minus 3.2 plus 4.1 equals negative 6.
And the directions for this are to solve?
Yes.
So you got to solve for x, right?
Yes.
Okay, so how do you solve for x?
You try to get n on one side and
Oh, I'm sorry, is this an x or an n?
n.
X?
N.
Oh,
Sorry.
n, I'm sorry. I heard x. So this is 2.3n
Yes.
minus 3.2 plus 4.1 equals negative 6. And so when you're all done, however many steps it takes us, right? At the bottom down here somewhere, we're going to have n equals, and that's going to be your answer, right?
Yes.
All right, now what steps do we have to go through to get that? How do we get n all by itself?
Take away 3.2 and 4.1.
So how do you get rid of those? Well, let's see.
You would, for 3.2, you would add 3.2 and it would cancel it out.
So we're going to add 3.2 to both sides?
Yes.
So we're going to do these separately. Okay, so let's add, let me do this. Add 3.2 here. And add 3.2 here?
Yes.
Okay. So you said it cancels it out because what's negative 3.2 plus 3.2?
0.
0. That's why they cancel out, right? So on this side, looks like we have 2.3n plus 4.1 equals, now what is negative 6 plus 3.2?
Negative 3.2.
Negative 3.2?
Yeah.
Okay, so let's see. That's 6.0. If I'm going to add or subtract these, I've got to make sure they have the same number of decimal places, right?
Yes.
And what do you do when you have one number negative and one number positive? Sounded like you subtracted them, right?
Yes.
So what's 6.0 minus 3.2? It's not 3.2, is it?
No, it's 2.8.
Yeah, because what did you have to do?
You had to borrow.
Borrow and make that a 10, and there's your 8, right?
Yes.
And there's your 2, and then we just bring that decimal straight down. And you said negative?
Yes,
Why is it negative?
because the negative number is greater than the positive.
Yeah, the big number is negative, so the answer is more negative than it is positive, isn't it?
Yes.
All right, so we've simplified the problem a little bit, but we still got a 4.1 and a 2.3, don't we?
Yes.
So what's next?
We have to get rid of we have to subtract 4.1 on each side.
Okay, so we have a plus 4.1, we want to get rid of it, so we do the opposite, you said, and that's minus a 4.1?
Yes.
And let's see, we'll minus a 4.1 over here.
Yes.
Again, what's 4.1 minus 4.1?
0.
Getting rid of it, we made it 0 again. So on this side, we have 2.3n equals, now what's negative 2.8 minus 4.1?
Negative 6.9.
Now how'd you get 6.9?
Because when you don't subtract negatives, if they're both negatives, they create a bigger negative.
So
Like
when you add two negative numbers together, which is what we're doing, right?
Yes.
You get a more negative answer, don't you?
Yes.
Right. So you got to remember, two negatives make a positive when you're multiplying, but two negatives added together give you a more negative number. And you said just add them together, that's 6.9. Right?
Yes.
All right. So we've gotten rid of 1, 2 of the numbers. We still got to get rid of that 2.3. How do we do that?
You don't, because you're solving for n.
Yeah, so we want the n by itself. So how do we get rid of that 2.3?
Divide by 2.3.
Yeah, okay, now why do you divide?
Because you will get a smaller answer.
Well, let's see. Up here, we were subtracting 3.2, so you added, right?
Yeah.
Because the opposite of subtraction is? Addition, right?
Addition, yeah.
Here we were adding a 4.1 and you subtracted because the opposite of addition is? Subtraction. Here you said we're multiplying, right? 2.3 times n. What's the opposite of multiplying?
Division.
Division. So I'm going to show division as a fraction like this, divided by, right?
Yeah.
And let's get rid of that 2.3 by dividing by 2.3.
Yes.
Now, what's 2.3 divided by 2.3? What's any number divided by itself?
1.
1. Up here we got a 0, didn't we? To cancel out the 3.2. Here we got a 0 when we canceled out the 4.1. But here when we divide, we didn't really get 0. We got 1n, didn't we?
Yeah.
But what's 1n?
N.
It's just n. I just lost it. Did I go back a page, Mike? I did. I got it. So we'll just erase that 1 and just know that 1n is just n. And now what's negative 6.9 divided by 2.3?
It would be 3.3.
Well, let's see. I'm going to take 6.9 and divide it by 2.3, right?
Yes.
So how do we divide by a decimal?
I haven't learned that yet.
Yeah. We don't like dividing by decimals, do we?
No.
So instead of dividing by 2.3, we're going to divide by 23. Right?
23, yeah.
Remember, we moved the decimal point to make it a whole number, right?
Mm-hmm.
If we move that decimal point, we have to move this one too, don't we?
Yes.
And bring it straight up. Now, here's the question. You ready?
Yeah.
23 times what is 6.9?
23 times 3 is 6.9.
Yeah, if you go 23 times 3, you get 9. You get 69, don't you?
Yeah.
So 23 goes into 69 3 times with no remainder. So what's 6.9 divided by 2.3? Now you got to be careful. 2 divided by 3 is 3. 9 divided by 3 is 3. But we're not doing 2 divisions. We're just doing 1 division, aren't we?
Yeah.
So what's our answer down here?
N equals 3.3.
Yep, what's our answer here?
3.
3. It's just 3, isn't it?
Mm-hmm.
Positive or negative?
Positive.
Negative divided by a positive is?
Negative.
Negative. If the signs are different, the answer is negative. So here's where you got to be careful. There's our answer, but we can't divide both of these separately. It's one division problem, isn't it?
Yes.
And so our answer is -3, which means if you put that back up into the original problem, it should work. So I'll leave the check to you with all of those decimals, but be careful when you multiply and add and subtract.
Okay.
All right, nicely done. Daniel, you still online with us for a moment?
Yes.
All right, well, congratulations, because right now you've got yourself a free movie ticket to the Friends at Maya Cinemas. So you'll be able to go check out a movie. Not a bad deal, huh?
Yeah.
All right, we do have phone tutors available until 5:30. A great problem that was, because I know there are students that see the 6.9 divided by 2.3 and they go 3 and 3 and
Very-
put 3.3.
Very tempting, yes, very
And
tempting.
as we saw, it's not 3.3, it is 3. So a great problem right there. Right now, we'll go back to the phones. Student from Reagan. Aditya, how are you today?
I'm good.
And your grade is?
6th grade.
All right. As soon as you're ready, let's hear the math problem you're working on.
I'm good.
So just read the problem when you're ready.
Oh, so it's a complex problem, but I'm just going to make it easier. The number 5040 is important. The number 5040 is important because it's divisible by all the integers from 1 to 12 besides 11. However, there is an integer less than 5040 with the same property. What is this number?
All integers.
Except 11.
Integers except 11. Okay, and you said there's another one?
Yeah, there's another one.
And it's less than 5040?
Yeah.
Okay.
And you have to find that number?
Yeah.
Okay. So obviously
so-
you're going to need to know divisibility rules.
So you know it's divisible by, I'm going to write them all down. You ready? I know it's divisible by 1, but 2, 3, 4, 5, 6, 7, 8, 9, 10, not 11, and 12? Did you say up to 12?
Yeah.
So it's divisible by all of those, okay?
Yeah.
So let's see, if it's divisible by 4, isn't it divisible by 2 twice?
Yes.
Okay. And if it's divisible by 8, isn't it divisible by 2 3 times?
Yeah.
So let's take that smallest number right there, and what's another number smaller than 5040 that's divisible by 2 and everything else? What would you have to do to 5040 to get that number?
To
No.
me, to find that number, I just found the smallest common multiple between 1 to 12 besides 11. That's what I did.
Okay, I'm sorry. Let me ask you again. The problem is asking for the smallest number that's divisible by all of those, or a smaller number?
A smaller number.
A smaller number. Okay. So here's what did you do? Did you use all of those numbers to find that?
Yeah.
Let me show you a shortcut, I think.
What?
Let me show you a shortcut, okay?
Okay.
What's 5040 divided by 2?
2,520.
2,500, you did that pretty quick. You must have done that already, right?
Yeah.
All right, so 2,520, let's see. Is that number still divisible by 2?
Yes.
It is, isn't it? Because it's even. Is it still divisible by 3? Yeah. We didn't take out a 3, did we? Is it still divisible by 4? And by 5, and by 6, and by 7, and by 8, and by 9, 10, and 12?
You've got about a minute to get as far as you can.
I think That's probably a smaller number that's divisible by all of those numbers. Is that right?
Wait, let me check.
And is that your
Yeah,
answer?
it is.
Is that it?
Yeah.
And we're done. And that was a shortcut. And we're done. Thanks for the call.
See how easy that was, Aditya? Are you still online with us?
Yeah.
Okay, well, you know what? Because that was a great problem, because I
It
know
was.
that there were some people going, all right, well, how are we ever going to find this number? That was a wonderful problem, so we're going to send you over to Johnny Rockets for a free meal. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30, but right now we have one more time to head on out to Berkshire with Mary Lou.
And we are back here at Berkshire Elementary School, ACES After School program, and I am here with Genesis. Hello.
Hello.
And what grade are you in, Genesis?
I'm in 5th grade.
Okay, what's your favorite thing about 5th grade?
My most favorite thing about 5th grade is mostly math and reading.
Oh, yay. That's a good thing to have favorite of, isn't it? Okay, well, we have a math problem behind us, don't we? And it involves reading, doesn't it? Your two favorite things. Okay, so it says a baker was going to arrange into rows of 28. The baker divides 432 by 28 and gets a quotient of 15 with a remainder of 12. We need to explain what the quotient and remainder represent. Well, first of all, do we need to make sure that the baker divided this correctly?
Yes, we do.
Okay, so he has 432, okay. Where does 432 go when we're dividing? Does it go outside or inside?
Inside.
Okay, let's put that inside, and that's actually called our dividend, okay? It's always our first number, so let's put 432 in the house, okay? And what is he dividing by?
28.
By 28. And the 28 is called your divisor, and that is our second number, and it always goes outside, correct?
Correct.
Okay, now we need to divide this. So let's think, 28 goes into 43 about how many times? Well, he said 1, okay, because he said 15, so we're going to double check. Do you think about 1? Yes? Yeah, because let's go with 1 and try it out. So let's put a 1 up there. Above the 3. Let's make sure we line it up. There we go. Let's put it above the 3. There you go. So 1 times 28 is?
28.
Okay, let's put 28 and we're going to subtract. So obviously that's going to be a 13 and we need to borrow, don't we?
Yes.
Okay, 13 minus 8 is?
5.
Okay, bring down your 5. And 3 minus 2 is?
1.
Okay, put your 1. And then bring down our 2. Okay, now they said 5, so we're going to put our 5 here, right?
Mm-hmm.
So 5 times 8 is?
5 times 8 is 40.
Okay, let's do our 0. And then 5 times 2, we know 10 plus 4 is?
5 times 2 is 10 plus 4 equals 14.
Okay, put your 14. But that's okay. Put your 1 and your 4. There, you're good. There you go. Okay, now we know that, yes, if we subtract, we have 12. He's correct. What does quotient mean?
Quotient means the answer of the division problem.
And a remainder is the?
A remainder is an extra numbers from the division problem.
Perfect. Good job. All right. Back to you, Mike, in the studio.
All right, you know what? We've only got a moment left, so what we're going to do is figure out who's going to see the Bakersfield Condors. Justin, put your hand in there. Grab one of those papers, and we'll see who the lucky recipient is. And who is that?
Genesis.
Genesis, a 5th grader from Berkshire. So Genesis, congratulations. You're going to see the Condors. There she is. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
The ancient Egyptians are known for preserving the bodies of their rulers after death. But these mummies aren't the only human remains to survive the rigors of time. How can naturally mummified remains also help tell stories of people